What's up, class? My name is Luke Phyllis, and I will be doing my presentation on Newton's laws of motion in real time. Newton's laws of motion in terms of space flight. For Newton's first law, a rocket is unable to accelerate upwards into space until an unbalanced force acts upon it. The Falcon 9 Heavy rocket has an overall mass of 1,420,788 kilograms while producing a force of 20,820 kilonewtons during liftoff, which means it needs a larger force to accelerate the rocket due to its larger mass, which explains Newton's second law. And lastly, what explains Newton's third law in space is called the ARED, which stands for the Advanced Resistive Exercise Device, which allows astronauts to exercise freely while in space by using vacuum cylinders to equalize the forces. Newton's first law of motion states that objects at rest will stay at rest and objects in motion will stay in motion in a straight line unless acted upon by a non-zero net force, which all comes back to the topic of inertia, which is the resistance of any physical object to a change in its velocity. And the experiment that I decided to do to prove Newton's first law is the coin flip into a cup. The coin has an inertia, which in turn means that it does not want to move. When I move the note card out slowly, the coin cannot override that force and it stays put. But when I pull the note card out very fast, the coin will stay at rest and just drop right in the cup, which proves Newton's first law of motion. Newton's second law of motion states that the force required to change the motion of an object depends both on the mass of the object and the desired acceleration, which can be proved by the equation force equals mass times acceleration. The experiment I chose to prove this theory was the rock versus crinkled up piece of paper. Newton's second law states that the change in motion of an object is reliant on the mass of the object and the accelerated force acted upon it. Even though the ball of paper and rock have been dropped from the same level, the rock hits the ground first with more force due to it being at a much higher mass than the paper. And Newton's third law of motion states that for every action there's an equal and opposite reaction. If object A has a reaction to object B will have the same reaction but in the opposite direction of the force being applied to it, which could be stood for F12 equals negative F21 because it is the exact opposite of the previous number. The experiment I chose to prove this theory was rolling two rocks into one another. In this experiment, the two rocks are applying both an equal and opposite force to each other. Both rocks are moving towards each other and eventually collide. The complete equal and opposite forces of the rocks are what stops both rocks when they collide, which proves Newton's third law. And this is my works cited. Thank you for watching.